Raul, Professor of Tech. Welcome. He will be speaking about LLMS, a hot topic today. Uh, Language models and cybersecurity. Welcome, Ramon. I think we met in 2019 that you were at the Ministry of Economy, but I am not 100%. Maybe, yes. You participated on an artificial intelligence panel. So it's been 6 years now. But I think you were there. Welcome. Okay. Good afternoon, everyone. First, I would like to express my gratitude to the organizing committee of this event of the South School. Internet governance. On internet governance, I will be speaking about LLMS and cybersecurity. I changed the title initially. It was AI and security, but I still call it like this. But it was 6 months ago, 7 months ago, that we have a news, a very important news about an AI expert at the University of Salamanca. And this person complained because some papers were taken down, and this is why I decided let's change the title. Let's do not speak about AI because content is subject to that. Is that, and this is precisely Curchao. He is the dean of the Universidad Salamanca, where Miguel was. What I will be doing during this conversation is to speak about LLMS, what they are, and then how it has been used, at least from the academic perspective. And this calls the attention of what is actually happening, both to speak about and to establish cybersecurity and to break it and to violate it. And then we have information about security offered, because at the end of the day, this is software and this is subject to attacks. I will be speaking about some things that call my attention about LLMs. And you know this, some of you know these things, but these are the things that call my attention. For example, lots of people say that this ChatGPT version has this capacity to accept a question, a query, a request, a prompt with 4096 up to 128 kilotokens. The token, and in general terms, there is this belief that token and worth are the same, but in fact it is not the same. We can initially say that a token is like a half a word, and for you to have the perspective, the Spanish dictionary has more than 90,000 words, while GPT 3.5 has a Vogue that has 53,000 tokens. Why do we say this? Well, because in this way we clearly reduce our Vogue. The alphabet or the language we'll be using to generate content or to do generation. And the algorithm used is a very simple algorithm that started in 1994, and it is byte per encoding. And I will take a text, and you are going to see in those texts which are the pairs of symbols. Technically, it is known as a diagram, and it looks that repetition frequency, and it is going to be replaced by a new symbol. And when doing this, the alphabet is going to be growing with new symbols, but then these symbols will be compressing with these new symbols the text that I am analyzing. And There is a constant of byte per encoding that I always tell my students. It should always be in your arsenal of algorithms. It is just like the byte pair encoding, but it is done efficiently in computing terms. But it happens once without being necessary. Looking the sequence of symbols, the more frequent repetitive diagrams linearly. I will be entering the text, if I may, and I will be analyzing pairs of characters, and each time by gram that happens or something that has previously happened, it will be replaced by this new. This is very interesting because it is possible to see that from the it can be optimum, and since it is optimum in compression terms, grammar is produced, it will produce the best grammar. This last thing, what you see there, it is going to be the grammar that express the string of characters. And this is an algorithm for those who want to do research and those who want to do programming as well. Another very important aspect that calls my attention is all people say that LLMs, part of the key of how it works is the mechanism of attention. And then you ask, what is an attention mechanism? And then what happens is that behind an attention mechanism, there's nothing but a transaction, arithmetic transaction, algebraic, of a matrix transposed, and it is another type of matrix, and it is very easy, and I will explain it to you with an example. Imagine you have a board with several readers, and those readers, where we see one, it means that it has read the corresponding book. If we have one here, then it means that the third one has read this book number 4. If you take this board, and each line becomes a column one by one. The first line is going to be the first column, and successfully, and then you multiply these two matrix. Immediately after that, you're going to get what is known as a matrix of the diagonal, and the symmetric matrix, and here we will have the number of books that each reader has read. But what is even more interesting is that books and have been read by reader number 1 and the last reader are 4. And why is this important? If you analyze the text and if you want to do is to understand the correlationship among words, what would be the meaning of the word salt? It will depend on the context. If I say salt of life, you can say pepper of my heart. So, in the context we have, through after reading all the documents in internet, attention mechanisms can see all this codependence. This is of course a simplification. This is an attention mechanism that in fact has 96 heads. Each head in an old chat GPT like the 3.5 sees through 96 heads all the text that you are asking it to process. But not only that, apart from this, It happens at multi-level, multi uh, multi-layer level, and they can understand different types of codependencies. So we have 96 heads in each layer, and 96 layers. Why do I say this? Because the attention mechanism, if you want to see it, it is down here. And this is going to give you an exit, and with that exit we will have a representation, and there you see worth and vector to represent worth, but it is a token. And this vector will have 12,288 fields, and each one of these is used to capture very important things, very important relationships in each token. And for example, if I have the worth, imagine there is a very typical example between a very typical example. For example, if if the vector that represents a king, if you subtract algebraically the vector that represents a male, and then you add the vector that represents a woman, then it will go from king to queen, and we will reach the representation of a queen. So what I am trying to do with this is that all these vectors for every token will have 12,288 characteristics that can be represented. And this is why it is so powerful. Of course, this is version 3.5 of ChatGPT. And it is the first version after the word to back, which was the first representation of worth vectors. Only 728 fields. Now we have 12,288. Those 12,288 will be fed into a neuron network, because all these networks have to be trained, and we have to train the weight of these networks. And it means that we will say it like this: what burden should be placed here, right at the entrance and at the exit of each one of these points in these tiny cells, which are the networks or the elements of the network. And if you make the multiplication of 12,288 times 49,152, which is 4 times this value, and then you multiply it times 2, you will have the number of pesos we're speaking about here only. And in this interconnection of this attention mechanism from one level to another. And if you multiply times 96, it is going to be almost 16 billion parameters. And from here, and it is not, it is the network, it is the responsibility or attribution of this network and not the attention mechanism. The number of parameters that we need to train so that one of these things, ChatGPT, works correctly. It is important because this number that I just told you is 2/3 of the number of parameters that we need to train in one of these things. So when someone tells you that an LLM is only predicting what is the word to be generated next, we have to remember that it is not the next word, it is rather the next token. And instead of having only one token, we will get an assortment of tokens, and then we will need to select out of those tokens which is the one we are going to be using or entering as a parameter of the LLM. And that parameter, or at least now, we are using this technique temperature, or it could simply be the first K elements. What is interesting about LLMs, and specifically the main component, which is transformer, is that it can be used in a very effective way in different types of scenarios, but specifically in the case of detection, because this is something very, very important in the field of cybersecurity. Because at the end of the day, what we do many, many times when trying to defend a network, for example, or a computer, is to try to identify patterns that we have previously characterized as malicious. And in this regard, we can use LLM in scenarios of zero shot, only a few shots. What is amazing and what takes us aback, at least from my experience, is the following. If you have an LLM and if you ask it, tell me, as an expert psychologist, if the next text, if this following text was written by a person who suffered from this mental condition, say yes with one, no with zero. And we could also ask, look, this is a positive example of a person with this mental condition who wrote this text. This is another person, blah blah blah. But this person doesn't suffer from this mental condition. You can work like this, but what it matters the most here is that if you could even think that it would be more effective. LLM would be more effective if you give it examples, but no, it is more effective when you give zero examples, at least in the contexts that I work with. What is the capacity of an LLM? You have experienced this, surely. A big part of the community that process natural language thought that I was closing this business because they were only wondering how to summarize text, how to process text and to interpret it, etc., etc. And then these mechanisms come and they can do it, and they can do it very well. It has been seen in recent times that there are many problems for long documents or to try to synthesize and to give, to summarize, for example, a movie, a long movie. But what is true is that I am certain that most of you, those who have tried to use an LLM, you've been taken aback by the capacity of of this technology. For cybersecurity, something important is the detection aspect, and in detection, many times people do not use an LLM, but another type of transformer who is transforming with bidirectional directions, and it is a variant of this type of mechanism that is known as betos, BERTs. And LLMs have many more capacities. It has been said that they can resonate. There are some studies that show there is this level of rationale, like a 7-year-old boy or kid. Recently, after not understanding, it is difficult for them to understand no. So, in your prompts, do not use the word no. It is very risky, it is something very important. It is a problem if you want to use LLMs in critical situations. There are scientific errors things that have been widely discussed. But all this has a price. One of the prices is that in order to do it, many cycles of GP1 are needed. In the previous slide, what we saw, where am I? We see the number of floating point transactions in order to train these devices, these machines, these tools. And this, what it shows, is the number of parameters that we need to calculate in order to make the necessary adjustment so that there is no hallucination, so that it is possible to have the right context in the questions. But all this is very expensive. For example, it has been said that $1 million is needed in order to train a model with 40 to 40 billion parameters. And the bigger the model, the bigger number of data needed. And here we have a problem that some researchers have. Let's say it is autophagia. What happens is that if you take an architecture to generate images as DALI does, and if you do this using synthetic images, what it will produce, what the model will produce, will not be something to be believed. Maybe you do not see it, but in some of these phases, in reality, several pixels are needed. For example, it is just like, for example, in the case of the face of the person who is there, synthesized. If skin pieces are needed. In all this, we do not have a defined adjustment cost. It has been said that the ChatGPT 3.0 OpenAI but hired lots of people, free people from Kenya, to censorship for not to allow the model to face misogynist, racist attitudes. And to avoid this, they had to use this labor. There are very important reports about the type of suffering, not only because of labor exploitation, but also because of the type of content that was censored. And it caused some disorders to those people who participated. Water is not included either, carbon emissions, etc. And to put it in perspective, making a fine adjustment of the ChatGPT 2.0, and it can take 10 minutes or it can take 10 hours. But in a fine adjustment of ChatGPT 2.0, CO2 emissions were comparable. That exercise on a transatlantic flight, or to go from New York to California, from California to New York. Now, what we will do is to go LLMs and cybersecurity. First, I will tell you how LLMs have been used in the establishment of cybersecurity. And here again, we're emphasizing to utilize compression capacity, understanding capacity to identify patterns and generation of information that LLMs have. Here, in this slide, the aim is to show you that in 2022 there were less than 5. You were able to count it with the fingers of your hand. the number of publications, academic publications in the LLM and cybersecurity intersection for 2023. And the number was higher than 120, 130, and that number grew twice as much in 2024. And here we are counting, it includes the elements and cybersecurity in the title and in the summary. But there are many techniques that happen that they do not have to necessarily include in the title or in the summary the word LLM or cybersecurity. For example, there is a lot of work about differentiated privacy, which is a technique used to avoid attacks to retrieve data. Techniques that can be used that in the title will not necessarily include the word cybersecurity or LLM. Clearly, within a growing number of papers, there is also an increase in the number of data sets being produced. And in some of the use cases that you can imagine, and also in relationship to the question asked by that lady back there, you can use LLMs and you can ask something to happen. And if something doesn't happen because of censorship, through breaking down, you can turn this problem around. And I want to speak about this thin line between establishing and breaking cybersecurity. There are lots of people who use GPT to do GPT, specialized GPTs in order to do market share test, uh, like the ones he's mentioning. There's one relatively new, but it is a result of a master dissertation. Ripper. Well, GPTs have been used to detect phishing, to generate market share or penetration tests, analysis of vulnerabilities, verification of data integrity, code, working with code. This is very common. Python tends to be very slow because of reasons of efficiency. You can say that many more people who do cybersecurity or those who try to is Rust, however you want to call it, Rust or Rust, and you can specifically use the capacity of these chat GPTs in general terms to allow very big prompts. I told you that the turbo version of ChatGPT 4.0 up to 128,000 words tokens, which are half words. This is a very easy example using a probe engineering technique known as React, where cybersecurity policy is being requested adequate to respond to ransomware attacks. There is a paper that you can easily find where you can ask how to generate a cybersecurity policy that will address this threat of ransomware. But thinking about how to use game theory mechanisms in order to minimize not the risk, yes, the risk of this type of attack. Obviously, the opportunities and the challenges we need to face when using LLMs has to do with bias. There's privacy, interpretability, and adversary attacks that we can use, and a modification to a prompt is going to cause the answer of LLM will be completely divergent. Of course, it is less mitigated if the prompt includes many materials. Now, in LLM cybersecurity, this is something that is very common because it is a test of concept. There are many applications where you have these systems based in agents, and you can imagine someone who receives, and what people do is to consult the CUB, the vulnerability exposure, to detect or to try to identify new registries about vulnerabilities recently published that have to do with a limited set of attacks or attack strategy. And with this information, the agent is going to use a planner, and it will be working with a specialized agents to use to exploit the vulnerabilities. And there are many cases of use, for example, where it is possible to synthesize cross-size CS or RF uh, request for trade, etc., etc., or execution of arbitrary code, blah blah blah. The only thing, fortunate thing, is that many of those papers do not stick to our scientific um, tradition of replicability. You publish a result, and then anyone can repeat it. Codes are not enough. You are not given the codes, and you do not know how the prompt was prepared in order to make agents produce the synthesis of these attacks, which is something good from the human perspective because you are not given your information is not be given to you to use it by anyone, by those who do not even know what they do. But the disadvantage is that from the scientific perspective, there are some aspects which are replicability aspects that cannot be achieved. Vulnerabilities, we know they exist in the three different levels in a simplified way: at the level of hardware, at the level of operational system, and at the level of applications. And at the end, I will show you a slide that tries to summarize the attacks we've seen and something that has happened using LLMs in each one of these three levels. If you find, if you see LLMs have been used to exploit a vulnerability, there is a space to write a paper and to get your PH. This is a very simplified example of how, in relationship to the comment of the colleague on how to change this situation through breaking down the problem into more problems, any chat GPT, in order to write ransomware. I will not speak about details because of time reasons, but one of the important, very important aspects when attacking is precisely this: the weaknesses between the interface human and machine, as we ask ChatGPT to show in a creative way the results of the prompt we're given, and we can say that we can ask an LLM to type a code in order to work in an interface. And here we have different possibilities with relationship to phishing type of attack. In fact, there are many studies that speak about how, in general terms, It is very difficult to tell if a text was written by one of these things or by a human being, but something funny, and this is something that is being recently investigated. Humans, we have found ways after all this to detect if a text was written by ChatGPT, and it is because of the words used by ChatGPTs, which are the first ideas to know that it doesn't sound normal. It sounds like something extremely well educated. I do not know. And you can imagine that speaking about breaking the security, GPTs have been used with CLM elements with the purpose of typing malicious codes to exploit different types of vulnerabilities for the generation of malware, for the generation of the malware variants. There are ChatGPT, ChatGPT that is prepared to produce a penetration test, and there are other ChatGPTs which are for censorship. If I can tell you everything, just simply ask. And evidently you can ask, how come? I've been told it is very expensive. I've been told it is very expensive to train a ChatGPT. I believe it takes a lot of energy, and CO2 comes in and is produced in a desperate way. And if it is not easy, it is not that difficult to know who is training this, because there's no way to hide the amount of energy used in this training, unless it is somewhere where it can be simulated. And these are the two most common GPTs. And this is what I told you. This is a paper published not that recently. I don't believe it is going to be published in something that can be filed in a magazine, because it has to get separated from the scientific protocol of replicability, because otherwise, because of ethical reasons, we wouldn't be able to include this in the codes. But this is what happens, and you have a planner, and it will see the SERP B. It will retrieve relevant information, speaking about which are very plausible attacks, to be synthesized in a new way to evade detection. And this is then given to the manager, and then the manager is going to go to one of these specialized agents. And here we have four families: cross-site scripting, the CSRF, and apart from SSTI, we have the execution of arbitrary code. Well, this is what I was telling you about. These are the boxes which are shown in gray. Those are levels or elements in this hierarchy of hardware, software. Hardware, software, these are things. And you cannot have a pH with this. And now I will speak about security in LLM. It is software. It can be analyzed and to find vulnerabilities. If one is found, it is like in saying if you find a mouse in the house, it means that there are many. So when one is found, more are found. So we have adversary attacks, which is the manipulation of the consultation to produce undesired results. Inference attacks to deduct information about the model. This is very commonly used. You ask, tell me who wrote it. Who wrote it? A woman or a man? This is exceptionally good. But at the end of the day, this is a problem. There are privacy issues that we need to look for. And does it mean that I have 5 more minutes? There I see I have 9 minutes. I apologize for this alarm. Here I will simply mention some of the elements. I do not want to stop. This is an attack to retrieve training data, and I will try to say general things. As LLMs have problems to understand, LLMs are designed to respond. So you need to say in an explicit way, you have to tell it, do not respond if you don't have the answer. So it is a model where if you say frog, there's someone is going to be jumping. So these researchers said, how can I retrieve data that was used in the construction of this model? And they said, well, what do you think if we do consultations, if we ask something to LLM through a prompt, but it is a one-word prompt, and what the LLM will do is to respond with another word. We know it is not a word, it is a token. So you can do this, you can repeat it several times till you have a string. And they said, well, let's make not very long strings, 256 words. And I will give an initial token. LLM will answer me with a token, and I will be using that token to ask another question, and then it will answer. And I will be doing this 200,000 times. Not only that, I will do it 3 times 200,000 times, so that it will produce different tokens in terms of this probability or possibility of this being the most plausible token. And what I will be doing is that once I have those 600,000 exercises, each one 256,000 strings, 256 words. I will select those sequences or those options or those tokens, those that are more shocking. In other words, if you want to say it like this, normally what LLM what it produces is not a surprise if we know what the answer is, the expected answer. But if you choose the tokens with less likelihood, you will be taken aback by what it is produced, by what it produces. So we're looking for those strings of tokens that happen a few times, and if a chain of tokens happen only once in all the documents I used to do this, then we have discovered a chain of tokens that was used, the document that was used in the construction of the model. They find sequences, big sequences, 87 tokens. in only one document. And they happen 10 times the first, 22 times the second one, and one means that it was in only one document. So with this attack, they were able to identify the document that was used in the training or in the construction of the model. Because why is it important? Well, because in the strings that were rescued or retrieved, here we have the categories, and some of those, specifically the ones you see in bold, has to do with sensitive data. Names of individuals, social security, number of social security in the United States. This is a sensitive information, and someone and put it or posted it in internet for reasons we do not understand. But at the end of the day, this is a document that has been used, and this document can be retrieved to know this information, this sensitive information, or private. And this is the way it should be. How did they do it? How did they verify results? How they did it? Authors, they work with OpenAI and with Google, and they were the ones who helped them verify all these attacks. Now, with this, I will conclude my talk. I do not know if you have questions. Thanks, Raul. Let's give you a round of applause. Thanks. I would like to see if there are remote questions, because I always forget asking them. It is my fault. They do not. I do not read the questions they typed. I have a question. I was thinking about this wearing out of people training the models. Would you please explain this? This is something that is a big curiosity to me. Once I read that it happens in big quantities in some countries, and this is why there could be some biases that have to do with culture, with how these people think. Would you please speak about this? The report is focused on the biases, but it is also focused on the suffering of all these people, and when having a certain type of characteristics and answers, when there is sexual content, for example, when there is inadequate content, well, they saw text that they had to read carefully, because it included very specific and detailed descriptions or narratives. Very tough scenarios, sexually oriented material. But obviously, there was also lots of information about the number the number of people who had to be hired, and they speak about thousands without saying how many thousands. It could be 2,000 or 3,000 of all these people from Kenya, and the salary by the hour. $1.32 to $2 an hour. And the work of these people is to review the text and to do censorship, to say this is inadequate, this is not. This level of censorship is going to be it's going to go through a fine adjustment, in this coding of the tokens. And mainly which countries? Where? The OpenAI report was Kenya. Okay, interesting. Good afternoon, Raul. Congratulations for this presentation. And I saw you took the attackers and cybersecurity, and they use this LLM to work with the script and to create a malicious code. So based on that, my question is as follows. What is the strategy and what is the framework currently adopted by institutions to include LLM in their defense capacity in cybersecurity? In cyber terms, how they defending, how do they use LLMs? I believe your question um, is a reason to have a long conversation. On the one hand, people use on a daily basis, they use people doing cybersecurity. People from SSIG, he and his colleagues use LMS to synthesize malicious code, but evidently to not only show what is happening, what could happen, but also to give a defense to the different companies, or at least to tell them and to offer services through this type of demonstration. And there is another aspect that has to do with legislation. How to empower with these tools, how to empower people, individuals, or corporations so that they can bring security and to do whatever is necessary. And there is very little legislation. At least in Mexico, there are two important legislative bills. One is by a MIT, and the other one was by a senator, Alejandra Lagunes. They are exploring in the Ministry of Technology and Science and Innovation Committee, having a group in a network. They call it ECOS to legislate about its use. And I believe, as we understand, we will be able to regulate, and this is a tool. And now you cannot give to a minor a permit to drive, but you cannot give a 7-year-old person a permit to drive. And there are some people who have their children riding horses since early. So, in the future, maybe, I do not know if I will say this, but we will have things that so that we can use this GPT, and maybe it needs a license that is going to confirm this. I have two comments, questions by the remote attendees, and I apologize with them again because I hadn't read their questions. Alejandra said, Dolce Vele developed a paper on African labor exploitation in the case of people who help train ChatGPT. We will look for it. And Alejandro said, which are the techniques that can be used in order to detect and to isolate potentially unsafe agents? Are there mechanisms to certify them to have a safe deployment? I believe this is a question for Hector, isn't it? Because we're speaking about identification of unsafe people, potentially people that can be manipulated. So, potentially people that can be potentially manipulated. Do we have more questions? There. An example of manipulation would be
antepasadas de Estados Unidos, ¿no?
the elections in the United States, where it was said that Trump won his first election through this collaboration with Cambridge Analytica. I am Manuel Santillan. I come from the state of Mexico, computing technology student, sixth semester, and what calls my attention is how fast this industry is growing. Speaking about the computing capacities we have, for example, Meta just published an important model. It can perceive 288 billion parameters, while if we do it locally in a normal computer, 7 billion parameters will be 32 gigabytes and RAM memory at least. So speaking about how demanding these models are that have grown so fast, so which are the concrete advantages working with this scale of a model, and what is the quantic computing tool could help us to overcome these bottlenecks to make it in real time. Look, yes, you're right. Jam GPT latency time could be unacceptable for decision making processes in critical situations. This is one problem that exists, and we will not be able to resolve while we do not have more powerful computers. But at the same time, we are limited by communications because in order to answer complex questions, you cannot do it in your local machine. You need to go to the cloud. And obviously, something that is related to what you are asking is the debate between using a big language model compared to a small language model. At the end of the day, so the concept, there are big ones, small ones, but it is a small. The small language models can be enough to resolve some problems, local problems. They can be executed in a machine locally, or if you want to do something not even complex, if you need to download this language model into your machine, it is a problem. So better run it in the cloud. This is my experience, and now which are the possibilities for this to be taken into a quantic computer? More than 20 years ago, there were other computing models, DNA computing, another one known as biological computing. Imagine you have two solutions. One solution represents one instruction, and another one. When you mix them together, there is an instantaneous reaction. Maybe this solution was not one instruction, millions, and here we have millions and millions. The mix can be a possibility to execute the program. Nowadays, and this is something that you saw this morning, because there was one talk about quantum computing and cybersecurity. Me specifically, I still believe quantum computing, use it to train a language model, is not at that level, at that commercial level. Did I answer your question? One more. Thanks. Diana Manrique from Colombia. Here. I've been working in cybersecurity and I've been assessing LMSs. But I wanted to ask you two things. Do you think there is a NIST regulation as something that has a regulation from the ethics perspective and security? Would you please repeat the first question? I cannot hear. Do you know if there is a regulation? Do you know if there is a regulation from the ethics perspective? Speaking about racism comments, you spoke about vulnerabilities in LMSs. entities like the NIST or FIRST? Is it regulated or are there other regulators? And do you think LLMS is enough to make a security analysis, or are there more frameworks, or standards, or regulations, or the roadmap? Something we could follow. For example, since I do security in LLMS, you make do you make decisions in LLMS or do you use LLMS? I assess security in LLMS, looking for vulnerabilities. If I do not know. I do not know if NIST or if other institutions have a product that says I will certify this LLM, but I do not doubt they are thinking about it. What is evident is that the legislation that exists, GDPR and this type of things, this is very general, and they speak about levels and levels of security that a product could have. But generally, they do not speak about LLMs. They speak about the product that uses artificial intelligence, and I believe it is exceeded. It has been surpassed, and if we speak about LLM in particular, then the only thing that you have, the only thing you have is this level of censorship, and maybe it will not be that good as LLMs have hallucinations. Anything can have hallucinations, and there's always, and this is a very common recommendation that each time you want to solve a problem, what you need to do is to ask LLM is to resolve tiny tasks. In other words, you should break the problem into sub problems in order to facilitate a solution. But in this breaking, the only thing we're doing is to change the flow of data, the flow of information, specifications of a code, for example, and when doing it, we can hide what the code is actually doing once it is complemented with other pieces. Well, now it is a very important point, very important in the scientific community to try to find ways to avoid some attacks, adversary attacks, as well as a model extraction or inference models. There are tests that show that tools exist to make a text anonymous, and that is not efficient enough. An LLM can infer things read in terms of authority. Based on what I said about model extraction, there are techniques such as differential privacy. It has been studied for years, and it is a huge set of training only once. It is a very interesting, important topic. Another, let's give him a round of applause. Thanks for sharing your knowledge with